Hey, what's up? It's your old pal, Mr. Cook, and we are going to work on the Unit 4 test review leading into the test. This stuff's pretty easy. A lot of it can be done just using simple arithmetic. I'm going to go over like some little simple rules as we go through each of these. So I'm going to take it like kind of section by section. And as always, just make sure that you ask your teachers if you need some help or further examples. And you know that you can do a bunch of these examples in the rest of the packet as well. Okay, so first, we're just simplifying the radical expression. So each one of these are square roots, and you kind of need to know how a square root works in this case. So the way that a root works in general is whatever the index is over here, the number that's in the corner of the square root, it tells you the group of numbers that you're trying to like compact into a single number. All right. In the case of a square root, it's not listed on there. It's kind of hidden, but the index is 2. So we're looking for groups or pairs of numbers to take out of the square root. So, here's how this works out. If I have to take the square root of 8 and I need to reduce it, you can always look for square root numbers that automatically square root every time. And like at this point, you should know at least a handful of them. Excuse me. Like how if I had to take 0 squared, that's equal to 0. So if I took the square root of 0, it would give me 0. Like if I took 1 and I squared it, that'd be 1. So if I took the square root of 1, that would give me 1. If I have 2 squared, that's 4. So if I took the square root of 4, that'd be 2. If I took 3 squared, that's 9. If I took the square root of 9, that'd be 3, and so on. Like there are a couple of them that you guys have probably already memorized. I think that a rule of thumb is to, have up to 100 or so memorized, up to from 0 all the way to 100 and know which ones you can take the square root of. Those are, I think that's like gold standard. You should definitely do that if you haven't already, memorized those numbers. So I'm just going to go ahead and list off the ones that we are going to, be going over shortly. All right, 8 squared, 64, 9 squared, 81, 10 squared, 100. Okay, so what we need to do is like work on a property of radical expressions where you can like break apart all the products of the number that makes up 8, and then use the square root. It basically like it uses multiplication and the idea of a factor to break this thing apart. So when we have the square root of 8, I know that the square root of 8 is 4 times 2. So if I wrote 4 and 2 there, like this is an equivalent expression. Square root of 8 equals the square root of 4 times 2. So this is really nice because I know that 4 is a number that I can take the square root of. So I can just split this apart as the square root of 4 times the square root of 2. And what is the square root of 4? If we go back over here, 4, if I take the square root of it gives me 2. So 2 is what that turns into, and then square root of 2 is left over. And since I can't take the square root of 2 evenly, I'm just stuck right there. This is my simplified expression. So like the goal with these radical expressions is to look for your square root numbers, 0, 1, 4, 9, 16, 25, 36, etc. If you can find those inside the radicals, then it's really, really easy to reduce your radicals. Number 2, the only thing that's a bit different is we have a negative, so get rid of the negative. When you take the square root of a negative, it turns into an I. So this is really the same thing as saying I times the square root of 28. Now it's just, you got to remember that the I is out front, but then you just take the square root of 28. So I know that 28 is 4 times 7. So this is the same thing as saying I times the square root of 4 times 7. And guess what? 4 is another number that we can take the square root of. So if I split this apart even further, I times the square root of 4 times the square root of 7. The square root of 4 is 2, so this becomes I times 2 times the square root of 7. And you can't take the square root of 7, so you just got to kind of leave it as it is. So this just becomes 2i times the square root of 7, and that's your simplified expression. For 72n to the 4th, so variables we're going to handle a little bit differently. So we're going to do this in 2 parts, the number and then also the variable, okay? So 72, in this case, it's really just helpful to know your times tables. I know that 72 is 36 times 2, but I'll show you that I can get, the same answer using something other than 36 and 2 in a second, okay? So I get 36 times 2, and then I have that n to the 4th power. I'm just going to leave that alone for right now. 36 I can take the square root of. So when I take the square root of 36, it's just 6. So I get 6. And then the 2 I can't take the square root of, so it just stays inside. 2n to the 4th. And then n. So I can use the fact that square roots look for pairs of numbers to take out and just kind of expand this out. So I've got 6 square root of 2, and then n to the 4th is n times n times n times n. And square roots look for pairs of numbers. So since I have a pair of n's here and a pair of n's here, that means that this one becomes a single n on the outside. So I have a 6 and then an n. And then this pair of 2's also becomes a single n on the outside. So I have another n that's multiplying in there. And now all of these n's are gone because they've both been square rooted. And I just have 2 by itself. So n times n is n squared, so this becomes 6 n squared, square root of 2. And that'd be our answer for number 3. And that's, completely simplified. You can just do it the number part and then the variable part. That's what I usually do with it. 18, that's another easy square root one because that's 9 times 2, so 9 times 2. And then we have r to the 3rd, which is r times r times r. So we can take the square root of 9, that's 3, so that goes outside the square root. And then we have a 2 left over. And then I have a pair of r's here, so one of them, this turns into one single r on the outside of the square root, so an r. And I have an r left over, so that goes inside the square root as well. And, that's it. I don't have to multiply anything together or anything like that. That's my simplified expression. So these are the first 4 problems. You can find a ton more of these in 4.1. So if you need some extra help, just go check those ones out. That's it for this video, and then we're going to go to the next section, and we'll try to explain that a little bit better too.